Well, here we are, part two, finding limits, and I got it one problem. We're going to do this one because a lot of good questions will come out of this problem. We're going to find the limit as this thing goes to 2. So the first thing you would try, and your thought process is to plug in 2 into that, and let's just see what happens. So if I plug 2 squared minus 3 to the or times 2 plus 2 over 2 squared minus 4, you can see that on the bottom at least that is going to be 4. I'm just curious. This would be 4 minus 6 plus 2. That would also be negative 2 plus 2, so that would be 0. So this is no good because this is undefined. That's undefined. Which means on this graph we have an undefined point or a hole in it at 2. Now, let's try to simplify this. So let's rewrite this. We'll say x squared minus 3x plus 2 over x squared minus 4. And let's try to factor out some stuff. All right. Well, at least on the bottom, we have a difference of 2 squares. So that's going to be 2 binomials, x plus 2, x minus 2. A lot of people are asking, well, can I cancel x's? Well, of course not. You cannot cancel x's. The only way you could, just on a little side note over here, the only way you could do that is if you had something like x squared plus 3x over x. If it looked like that, then you could cancel an x out of here, and this would be x plus 3. But this doesn't look like that. This over here is just, there's not one term out of all these that you can cancel. So that is not it. On top, this will also factor into 2 binomials. And if you're skilled at factoring, you notice that this plus 2 and this is plus 2 here and has a minus here. So I got a plus here and a minus here. When that happens, I know that both signs have to be negative. And then I say, okay, well, what can I multiply together to equal 2 and add together to equal negative 3? And that would, of course, be negative 2 and negative 1. So what you do at this point is take the like terms. Now, if you have a whole quantity like this, like that whole quantity and that whole quantity will cancel. So boom, boom, like that. What's left over will be on the top x minus 1 and on the bottom x plus 2. And those parentheses aren't really necessary at this point. But if we now evaluate this at our limit of x approaching 2 and we plug in a 2 in here, we should get a value that this limit will equal. So if I put 2 in on the top, minus 1, and 2 plus 2 on the bottom, that's going to give me 2 minus 1 on top, which is 1, and 2 plus 2 on the bottom, which is 4. So we can say that the limit as x goes to 2 of x squared minus 3x plus 2 over x squared minus 4, that's our original one, equals 1/4. And I'm quickly going to sketch the graph of this now, just so you see what's going on. On the graph at negative 2, there is something called a vertical asymptote, okay, which is this fence in which the graph avoids. And so this graph comes up like this, goes like that, and it starts down here somewhere, infinitely close to it, and then crosses somewhere right about here. I gotta be careful how I draw that. So like that, except that's more curvy right there. Okay, that's curvier right there. But the point in which we're interested in is 2, right? That's why we're evaluating this. X equals 2. At that point, as x equals 2, this is this part right here is continuous because as I approach as I approach this from the left direction, it is right there. And as I approach it from this direction, it is also right there. And you can see that it's going to be 1/4. And if you try that on a, whereas 1 would be right here, this is just a little bit of the way up. A little bit of the way. And if you try it with a TI-84 or something like that, and you zoom box around this area right here, you can kind of see that it does approach 1/4 or 0.25 really closely. The question, though, and the next video will be on this, is what would the limit as x approaches -2 be of this function? All right, what would that be? And I invite you to check that out. All right, I'll talk to you later.